Welcome to qnawire.
We are to draw the least stable conformer for this compound. So remember that the least stable shared conformer that we're going to have will have substituents, or most of the substituents, in actual positions. This is due to something called the 1-3 axial interaction that comes from the actual position on one of the carbons and the one that is a little bit away on both positions. So in this case, it will look like this, and the interaction that we have in between these guys is going to destabilize our chair conformation. So in this case, what we want is to generate the least stable compound. So let's start by numbering our carbon atoms, and in that way we can continue as drawing things in our cyclohexane. So this is going to be carbon 1, carbon 2, carbon 3, 4, 5, and 6. And just for reference, in our cyclohexane, these are going to be 1, 2, 3, 4, 5, and 6. So the ones that are going to have substituents are going to be carbon 1. In this case, it's going to have the following substituent. I'm going to put it in red just to emphasize that this is going to be in the actual position. Remember CH3, CH3, H3C, just to make it look good. Now in carbon 3, we're going to draw a fluorine atom in the actual position. This is going to be looking up, down here. Here we're going to have our fluorine atom. And at carbon 4, in our actual position, we're also going to put it in the actual configuration. In this case, it would be right here, our CH3. Remember that even though this actual position is looking down, it is going to interact with other actual positions in which are on the third carbon atom. So for example, over here on carbon 2, we're going to have a nitrogen, and the weak interaction that we have in between the CH3 and the hydrogen is also going to destabilize. So that is why having our substituents in actual positions is going to be the least stable configuration. So with that, it would be all. Thank you very much and have a good one.